Hey guys, this is Coach Lowe, and we're going to talk a little contextual geometry. This is Chapter 6, Section 4, Isosceles triangles, and we've talked a little bit about isosceles and equilateral triangles this year already. So we'll get this quick review and work a few problems, and then I'll see you in class. So that'll be awesome. All right, so let's talk about isosceles triangles. If you want to draw one real quick on your paper, in your notes, and let's go ahead and label it. So we have isosceles triangle has at least two sides congruent, so let's mark these sides. These are called the legs of an isosceles triangle. This angle is the vertex angle. And then these two angles at the bottom are called base angles. You know, I really want to sing that song, don't you? I'm not going to, though. You can sing it if you want. All right, and this is called the base. Yep. All right. So as we look at these triangles, there are a couple of things that we need to point out. First is Theorem 6.2, which is the isosceles triangle theorem. If two sides of a triangle are congruent, so let's say this is A, B, and C. If two sides of a triangle are congruent, then the angles that are opposite those sides are also congruent. So if two sides of a triangle are congruent, see, we can abbreviate this crazy, can't we? Then the angles opposite those sides are congruent. If you need to pause, then please do that. All right, so Theorem 6.3 is it's talking about the median. So the median, remember, the median comes from the vertex and goes to the opposite side midpoint. All right, so the median of the triangle that goes from the vertex angle is on the perpendicular bisector of the base, and the angle bisector of the vertex angle. Wow, we have a lot going on there. All right, so the median. Here's my median. The median comes from the vertex of, so it would be the vertex angle, which would be angle B. It's perpendicular to the base, which that's a new thing. Median just comes from the vertex and goes to the midpoint, but in an isosceles triangle, it's also perpendicular to the base, and it also splits these two angles in half, which makes them congruent to each other. So these two angles are equal to each other. So ABD would be congruent to DBC. All right, good stuff. So make sure you have those two theorems in your notebook. All right, let's practice on one here. So this will be example number 1. Let's find the values of some missing variables here. So if you want to sketch this just real quick, looks kind of like a kite. This degree measure is y, and this is x degrees. This is 35 degrees, and this is 45 degrees. Let me go ahead and draw a line down this way. And it does not want to stay there, does it? Nope. Come on now. Work with me here. Wow. I don't know why my writing tablet will not let me do that, but we'll just work with it. We'll just go. All right, so this side and this side are congruent, and this side and this side are congruent. So hopefully you can see I have an isosceles triangle here, the red one, and I have an isosceles triangle here. Now I have a lot of different triangles, but let's pick out the sides that are congruent. So this is my vertex angle of the green. Then I have congruent sides here. Those are my legs. That makes these base angles that are congruent to each other. So y is 45 degrees, or y is 45. So what would x be? This is my vertex for the red. This is vertex angle. So what's the value for x? Yeah, 35 degrees. Good job. So x is 35. All right, good work. Okay. So theorem 6.4 is the converse of the isosceles theorem. So 6.4 says if two angles of a triangle are congruent, then the sides opposite of those angles are also congruent. So just flipping that around. If two angles of a triangle are congruent, then their opposite sides are congruent. All right, so let's get an example of that one. Let's see if we can figure that one out. All right, so draw this with me. So DF and E. And let's mark these sides congruent. And this is 2x plus 2 and 3x minus 3, angles 1 and 2. All right, so let's find the measure of angle F and then DF and EF. So let me give you some more information. In triangle DEF, angle 1 is congruent to angle 2. We already know that because these sides are congruent, don't we? And let me give you the measure of angle 1. The measure of angle 1 is 28 degrees. Find the measure of angle F, DF, and EF. All right, so the measure of angle F, DF, and EF. Okay, so angle 1 is congruent to angle 2. By the way, if you guys would like to stop the video and go ahead and try these yourself, please do so. All right, so the measure of angle 1 is 28 degrees, which means this one is 28 degrees. I know there are 180 degrees in this triangle, which means I can find the measure of this angle right here of DFE. The measure of angle F, or DFE, is 180 minus the sum of these two angles. So minus 28 plus 28. So I'll do the parentheses first. 28 plus 28 is 56. So 180 minus 56 is 124 degrees. So the measure of angle F is 124 degrees. Now I need side DF and EF. I need those links. So let's see what we know. We know those sides are equal to each other because this is an isosceles triangle, and they told us the sides were equal to each other. So let's find those sides. 2x plus 2 has to be equal to 3x minus 3. So subtracting 3x from both sides gives me negative 1x plus 2 equals negative 3. Subtracting 2 from both sides gives me negative 1x equals negative 5, or x is 5. All right. So that doesn't give me the side length though. When x is 5, 2 times 5 plus 2, 10 plus 2 is 12. So DF is 12, which means EF had better be 12. Let's do a quick double check. 3 times 5 is 15, minus 3 is also 12. So that does check. Sides are 12, angle is 124 degrees. Awesome. All right, let's try another example. And then we'll work some more when I see you again soon. All right, so let's draw this triangle. And let's go ahead and label it ACB. And this angle is 4x plus 2. And this angle is 5x minus 7. And in this triangle, AB is congruent to AC, and the measure of angle B is 5x minus 7. The measure of angle C is 4x plus 2. I want you to find the measure of angle B and the measure of angle C. So you can pause the video and do that. All right, now that we're back, since the sides are equal, I know the angles opposite those sides are equal. So let's talk about opposite sides. This side, if I just put an arrow out in front of it, angle C is opposite that side, right? And this side, if I just arrow out in front of it and see which angle it meets, it will meet that side. All right. So those two angles are equal to each other. So 5x minus 7 equals 4x plus 2. We can add 7 to both sides. So 5x, that's gone because it adds to be 0, equals 4x, and 2 plus 7 is 9. Subtracting 4x from both sides, 1x, or just x, equals 9. All right, they didn't want x, though. They wanted the measure of angle B. So 5 times 9 minus 7. Plugging it back into this expression, 5 times 9 is 45, and 45 minus 7 is 38. So the measure of angle B is 38. Measure of angle C better be 38 also. 4 times 9 plus 2. 4 times 9 is 36 plus 2 is 38. So the measure of angle C is 38 and the measure of angle B is 38. That's awesome. They're supposed to be equal to each other, aren't they? So that's a great check for us. All right, guys, that's it for the isosceles triangle. Remember, equilateral triangle. On the equilateral triangle, all angles will be 60 degrees, so you may run into one or two of those in the assignment when I see you again soon. All right, so hope this makes sense. Write down your questions that you have for me, and we'll talk about them next time I see you. This is Coach Lowe, and I'm out.